Good day, everyone. We are already done with different methods of calculating um, or summarizing and organizing data. So today we will be discussing about probability. When we talk about probability, so say for example, if you would be asked, uh, what's the probability that it will rain today? So commonly we will answer in terms of percentage, probably 80 to 90%. But in our those percentages just converted from a real values. It might be point 0, point 0.8 or point 0.9, and these are calculated values. Later on, we will be calculating those values in our next topics or in the topics to come. Before that, let us have a recap first on the different types of data or categories of data. There are two categories of data. First is quantitative or the numerical data. These represent measurements or counts, meaning numbers. Next is we have categorical data. So we have qualitative or categorical data, which are classified according to criterion. It might be the degree of how you agree with um, some opinions. Okay, so those are example of qualitative data. You might say agree, disagree, strongly agree, and so on. Now, this data, if we are going to conduct in engineering data analysis, we will deal with these types of data. And how we do that, that is through experimentation. Now, first is observation. Now, when you an observation, it can be part of an experiment. When you observe, you record information. It might be numerical or categorical. Then, sometimes for categorical data and even numerical data, we have to convert them into numbers or represent them into numbers. Say, for example, how many of students who agree with the new, say, new classroom policy? How many students have disagreed? Or you can also say how many students are female or are male. How many students have birthday have a birthday on the 16th of a month. So yun na, we will be representing or recording those types of data or categories of data, and that is through observation. So in an experiment, so we gather data, set of data, and here in engineering data analysis, we commonly call it statistical experiment. Because based on the data we have gathered, we will be analyzing them through statistical methods. When you uh, when you have a set of data, then that means we have to group them. We have to categorize them, or we can just like what we have done in the methods of summarizing data. We group data using either tabular methods, graphical methods, and so on. Now, this group of data is called the sample space. The sample space contains all the possible values, all the possible outcomes of an experiment. So when you experiment on, let's say, the the average time that the average time when you when say the average time of student when walking from say Saint Columban to SB or Saint Benil building. So you will have in your sample space, you will have there all the possible values of the time that it would take for a student to walk from SC building to SB building. And we denote it with the the variable s. S represent the set of possible outcomes, or this is a sample space. Now inside the sample space, we have what we call element. So one outcome is called an element. One possible outcome is an element of the sample space. So sometimes it's called a sample point. The possible outcome can be called sample point or an element. Now, if you're familiar with sets, sets are represented by these by uppercase letters, uppercase variables, or uppercase letters. So elements may be represented by lowercase letters, or symbol for element would be this one, an element. So it's an element of a set or a sample space. For example, this one, what are the possible outcomes of flipping a coin? So how do we represent this in a set? So again, our sample space. Again, we have two possible outcomes in flipping a coin. One is head, the other is tail. So if we will write it into a set notation, so we will use H for head. Now if we will let H represents head and T represents tail, so the possible outcomes of flipping a coin are head and tail. And you have to take note when you see these symbols, the opening and the closing braces, that represents a set. So the sample space or set S has an elements H and T, or the head and tail. And these elements are again the possible outcomes when flipping a coin. Another example is this one. Consider the experiment of tossing a die. If you are interested in a number that shows on the top face, so what would be the sample space? So the sample space again consists of all the possible outcomes. So if you know what's a die, no kanang yung gitawag na die is duha ka buok ka die. So kanang 6 ka buok noong the uh, cubic object kanang dulaon na to. If you're familiar with snake and ladder, you will be tossing a die. Now this cube here has 6 faces. Each face represents a number from 1 and 2, 3 until 6. Ano na yung mga dots. 1 dot, 2 dot, 3 dots, 4, and so on. So which means the possible outcomes for tossing a single die, so if we will denote S for the sample space or all the possible outcomes, then that means we will have 6. That's and kani one dot, 2 dot, and uh, so on. Okay, wait. Okay. So the possible outcomes are again 1, 2, 3, 4, 5, and 6. And remember to put a opening and closing brace when writing a set. However, if you're interested only whether the number is even or odd, what will be the sample space? So if you are interested only if it's even, so you just have to take those even numbers and let's just say since S represents all the possible outcomes, let's just use A if it's even. So what are the possible values for or outcomes na even ang magawas, and that's 2, 4, and 6. If we are only to consider all the odd numbers, that's 1, 3, and 5. Writing comma represents it's a different outcome. So you have 1, 3, and 5. So Uh, okay, sorry. So these are the possible values you have. A can be 2, 4, 6, and B can be 1, 3, 5. So many possible outcomes kung ating i-consider kay puro add lang ang magawas. And if we want to consider that all number, even rather, if we consider that puro add ang magawas, and that's this. However, if the question there here the I is we just want to know if even or odd, so which means it's either we just say even or add. So if one ang magawas, it might be add, and that's odd number. If 4 ang magawas when tossing a die, then it can be an even. So mo ni ang possible outcomes when kung we are only interested with uh, whether it is even or odd. But again, tanaw na gyapon na nimo ang iyahang value. So for example, kung 6 ang magawa, so that's even. So even ang ato ang ibutang. Okay. Another way of uh, another way of writing the possible outcomes or representing a possible outcomes is through tree diagram. As you can see here in the previous slide, you have we are writing or showing the possible outcomes through a set notation. This is actually an example of set notation. Now we write all the outcomes. Another is through a tree diagram. How does a tree diagram looks like? Now let's consider this example. An experiment of flipping a coin. So when you flip a coin, there are two possible outcomes. That's either head or tail. Then flipping it second time, if a head, of course. So check the conditions. When 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 a head, of course, when flipping a coin, so flip na pud nimo siya balik. The other condition is when a tail, of course, in the fifth, first flip rather, then we will toss a die once. So there are now two objects here, okay, a coin and a die. Now for a coin, let's just use the possible outcomes for a coin. Let's use A for the coin. The possible outcomes for a coin are head and tail. If we will denote B for the possible outcomes when tossing a die, so that's someone 1, 2, 3, 4, 5, and 6. So when we are asked for the possible outcomes based on this problem or condition, so sa itong sample space ani. So take note again of the condition. Ang first nga gibuhat is we flip a coin. When ang mugawas sa pag first nga flip is a head, so i-flip na po na to siya balik. So which means if we get a head, mo flip tag coin. So there are two possible outcomes na po. We will use an ordered pair since duha man ka duha man ta nag duha ka mo kang atong actions na gibuhat. First, flipping. Second is either flipping again a coin or tossing a die. So this is the first gibuhat na to, flipping a coin. If it's tail, so say sunod button, flip again. And when flipping a coin, there are two possible outcome. It's either a tail gyapon or a head rather or a tail. So mao na ang possible outcomes kung ang first na magawas is head. However, when we flip again, when we flip the coin and tail ang magawas, so sa may button, we are going to toss a die once. And based on this, we have 6 possible outcomes sa pag-toss a die. So, ang pares ni tail is could be 1, it could be 2, could be 3, or a tail we dayon pag next na pod nimo nga toss, it could be 4. Or if you flip the coin then tail ang mo gawas, then toss ka og die, then pwede 5, or pwede po 6. So based on this example here, what din yung possible outcomes? You might get ahead sa first nimo pang flip, so which means kinahanglan ka mo flip sa second. So sa second mo flip, it's either head or tail na po mo gawas. However, sa pag first nimo nga flip sa coin, tail lang mo gawas, so you have to toss the die once. And when tossing a die, there are 6 possible outcomes. 1, 2, 3, 4, 5. All in all, no, our sample space contains pila man ka possible outcomes. So 1, 2, 3, 4, 5, 6, 7, 8. So there are 6 possible outcomes. Now this is how we represent the possible outcomes using a set notation. This is just one method of set notation. However, if we will use a tree diagram, ingon ani ang outcome. Okay, so this is first instance, no, sa as the start pa. Then when you flip, so money out of first outcome. When you flip the coin, then head ang mo gawas. Then second is you have to flip another flipping in the coin. So possible outcome is head, or it could be tail. So this is one sample point. This is another sample point. However, if tail sa first na pag-flip, you have to toss a die once. So the die, tossing a die can have an outcome which might be 1, 2, 3, 4, and 5. So money. So in a tree diagram, money ang possible nimo nga answer. So it's up to you which one is easier. It's either you use set notation or a tree diagram. Although sa tree diagram, it would need space on your paper, but as you can see, mas dali siyang kita. Now, these are your sample points or your possible outcomes. Okay, so sorry for that. There's a problem, I think so. So the possible outcomes are again, it's head, tail, tail 1, tail 2, tail 3, and so on. Now, this one, ang yang gipakita is tapad lang niya. No? But you can also use the ordered pair because sumot na ordered pair, dili sila pwede mag-bind. Okay. Now, we have presented there. Oh, what happened? Okay. In the previous slides, we have presented here all the possible outcomes in the sample space. Now, what if I would ask you if we will consider only when a head occurs? So, what may consider kaya ang head lang? So, these are the possible outcomes. Diba? Kung sa first flip, head ang magawa. So, that means ang second na tumbuhaton is to flip again, and the possible outcome is head and tail. Now, this one, kanisha, if we will only consider this portion here, we call it an event. No? It's a within a within the sample space. Now, a group of possible outcomes within a sample space. Now, we call it subset. When you're familiar with sets, so a set might have a set inside it, so we call it a subset. Now, an event is considered a subset of a sample space. For example, if our sample space is the students within a classroom, so one possible event is that the male students inside the classroom, so that is a subset, or it could be the female students inside a classroom, which also a subset. Another subset is that say, female students wearing a uniform inside the classroom. So that's a set within a bigger set. Now, if we have an event, we also have a complement event, and sometimes it's denoted by an apostrophe or a bar. If as you can, if we will go back to our previous slides, just go back to the previous slides. Mm, where can I go? Okay, if you will go back to this slide, as you can see here, nagsulat ko mga uh, variables, no? Uppercase to represent a set. Now, these A and B are actually subsets of the sample space. We can have that subset. Pwede natin na siya tawag na subset. So, these are events, possible events. Kani siya, this is also a possible event kani when ang head ang una mo gawas. It's an event. It's a subset. Then the complement would be kung unsa ang wala. So if my event is denoted by letter E, the complement of an event would be A prime or E hat. So again, this denotes all the possible outcomes na wala sa E. So not in E, or the complement of event E. So if we have a sample space na students inside a classroom, and if our event, let's say A man yung gidenote diri. So if our A is the set of all male students, then the complement of A will be the set of all female students inside a classroom. So manay meaning of complement. It's the elements not found on that set, that subset. Example, if we will let R be an event wherein a red card is selected from an ordinary deck of 52 playing cards. Now, if you're familiar with cards, baraha, there are 52 cards there. Okay, and uh, 13 of which kay hearts and its color red. 13 of which are diamond, which are also in red na color, and another 13 will be for the spade, uh, which are black, and another 13 be for the clubs, kanang kamunggay. Sorry for that. These are black, so kani sila black, kani sila red. If we are asked with this question, now if R will be the event that a red card is selected from an ordinary deck of 52 playing cards, so let S be the entire deck. So meaning, ang tibuok na tong deck of cards, kay 52 man siya kabuok, so muna ang sulod ni S. Then, which means, the complement of R are all the cards na black, not red. Okay? So if this is our event R, so paano siya nga group here is our R prime or complement of R. So that's an example of complement. Another, if our sample space is contains these outcomes or elements, you have book, cell phone, MP3 player, paper, stationery, and laptop. if you have an event A, uh, which contains book, stationery, laptop, and paper, which means si A kay na si book, stationery, laptop, and paper. Kaning nabilin are all the will be the complement of your A. So, ng cell phone and MP3. Now, in an event, we have what we call different operations. One is which is intersection. When you say intersection, like just like a road, diba? We call it the intersection. No, wherein two roads met. So in events pod or in sets, now kani siyang intersection is the area wherein these two different types of set have common values, or they have common elements, common possible outcomes. So the intersection of events, which is denoted by the symbol kani. Now, this contains all the elements that are common to event A. This is event A, and this is event B. So this is how we read the intersection of A and B. Example, if we have two possible or two events, A and B, so associated with an experiment, in other words, A and B are subsets of a sample space, of course. No, kung all events, kung na mga events na gina-consider, ang pinakadako nila is the sample space. In set, we call it the universal set, which contains all the possible values or elements within an area of being studied. So, naka-event A dire, can have an event B. So, for example, in tossing of a die, we might let it be event A, that if a number occurs, and B, the event that a number greater than 3 shows. So, check mo na kay duha consideration. A, even number. So, what are the possible outcomes or possible elements? Dili lang to sa taas kay nanalit mo. Siya isulat na. Okay. For A, you have even numbers. So what are the even numbers in a die? So it can be 2, 4, or 6. Next is, you have another condition there, so we'll use event B. Yung gingon is that number greater than 3 shows. So wala niya gingon kung even ba or odd, which means pwede even, pwede add. So greater than 3 are 4, 5, and 6. So if you were asked, what is the intersection of event A and event B? Your answer would also be a set. Okay? So instead of common nilang duha, common, you have 4 and 6. So our answer will be 4 and 6. So this is how i-represent na siya. Our sample space again contains all the possible outcomes sa tuwang area nga studyhan. Okay, since die man ni siya, one die lang, a single die, possible outcomes are 1, 2, 3, 4, 5, and 6. So again, the intersection of A and B is the elements or the set or event containing 4 or 6. How about this? If we will let E be the event that the person selected at random in a classroom is majoring in engineering, and F be the event that the person is female. So, what is the intersection of E and F? So, unsa daw ang atong answer nga major siya in engineering, dayon female pagid siya. So, simple, if words na niyang gibutang diri is words na patong answers, the intersection will be a female engineering student. Okay, diba? Engineering siya, female pagid. So that's the how we use intersection. Another term is mutually exclusive events. So you have their intersection. This is contains all the possible outcomes which are common to two sets, three sets, or is common to different sets. When we say mutually exclusive, this is an event wherein two or more events have no common possible outcome. So we also call them disjoint events. Dili sila mag-join, kaya wala man sila common values. And in a disjoint event, in disjoint events rather, the intersection is a null set, meaning wala. And this represents null, meaning wala sila common value, wala sila intersection. We also have what we call union. When we say union, we combine two or more sets. So kung unsa may, for example, even though they are disjoint or bisang pag na sila intersection, so when we use union, ato gina silang i-combine. So in the union of two events, A and B, say for example, so the union of which contains all the elements that belong to A or belong to B, or both elements that belong to B or both. So if you have A, say for example, the elements of A are 1, 2, and 3. The elements of B, event B, are 3, 6, 9. Therefore, the union of, since they have intersection, the union of A and B contains all the outcomes that are 1, 2, 3, 6, and 9. We don't need in a writing set, no, we don't need to repeat the value. Mamay common nila. Now, say for example, if two events are disjoint, say this is 4, 5, and 6. If we want to union or to join A and C, so the union of A and C will be or will contain all the elements of A and C, and that is 1, 2, 3, 4, 5, and 6. So that's how union works. So this is how we denote, by the way, no? Gamit ako, but this is how we denote union. Now, another way of representing events is through Venn diagram. So we use circles here and a box. The box represents the universal set or our sample space. And these circles represents the events or the subsets within your sample space, the set within your sample space. So say for example, if we have events A, B, and C. A contains kani sulod sa ani nga lingid, that's 1, 2, 4, and 7. B contains 1, 2, 3, 6. C contains 1, 3, 4, 5. This portion here, kani siya nga portion, okay nyo nang ikuha ng circle. This is the intersection of A and B. Okay? This portion, tanawa ang mga lingin, this is the intersection of the three events. That's A, B, and C. However, if you will consider this, kani, this is the union of A and B. So, nanaw na ito pag-interpret ang Venn diagram. So, another example is this one. If you take a look at this, you have no. There is a possibility that sets are disjoint. No, mao na itong i-discuss ganina. So, you can see B and C here are disjoint. Wala sila common. However, A and C have common value na din na therefore na sila intersection, and B here is a subset of A, which means A is an event inside sample space, B is an event inside A or within A. Okay, let's have this example. You have sets A, B, and C. So these are the values. It's the intersection of A and B. So my A, B common. You have 1 and 2. Okay, please check. No. You have we have again B and C. So siya B and C. So the muning linya ni B, muni ang linya ni C. So their intersection contains 1 and 3. Next we have A and C. This is now the union. Check the symbol. So this will contain so muni kang A, muni kang B, C rather. It will contain 1, 2, 3, 4, 5, and 7. Next, we have the complement of B. Nag-intersect na to ni C. Okay, the complement of B, if this is B, sa may wala ni B, which means ang wala ni B, kani tanan. Na dinhi. So, the complement of B contains 7. So, talang i-write dinhi. The complement of B contains 4, 5, and 7. Meaning, dili possible outcome or dili element ni B. Then, itong intersect ni C. So, unsa may value ni C? That's 1, 4, 5, and 3. So, common nila will then be 4 and 5. Next, the intersection of the 3. Kung tanaw ninyo dira, there's only one value sa intersection nila. That's 1. Next, we have kung sa nato daw ang union. Now, let's get first the union of A and B. Then, we'll get the intersection of the union of A and B with C. So, sa may union ni A and B. So, the union of A and B contains the elements that A and B. Okay, the union of events A and B contains all the possible outcomes of A, both A and B. So these are 1, 2, 3, 4, 6, and 7. Then we will get the common value of the union of A and B with the common possible outcome of the union of A and B with C. Okay, intersection yung gingon dire. So our C contains 1, 3, 4, 5. So we have 1, 3, 4, like 5. So the answer will be 1, 3, and 4. So muni ang mga values. So muni itong i-answer. Okay, we have some definitions or theorem here. So we have the intersection of an event with a null value or null set. Null event is null. So wala sila intersection. You have the union, A, the intersection of the two, since these two are complements, wala gina sila intersection. However, when kuha ng nilang union, so that would contain the sample space. The complement of sample space is null because the sample space again contains all the possible outcomes. So, yung complement is null. Same, vice versa. Next, this is called double negation or double complement. So, complement of A, then gi-complement pa yun, so would result to A. Then, when you have this group, this is the Morgan's theorem. So, you have the quantity, the complement of the intersection of A and B is equal to the union of the complement of A and complement of B. The complement of the union of A and B is equal to the intersection of the complement of A and the complement of B. Say for example, this one, we have a card is selected at random from ordinary deck of 52 playing cards. We have 3 events. Card is red. Second event is card is Jack Queen or King of Diamonds. Third is the card is an ace. So what is the intersection of A and C? So again, A is red, B is ace. So again, there we have four aces. So, pagkaalas can be hearts, diamond, can be heart, can be diamond, it can be a spade or a clover. Now these two here are red, kani sila are black. So which means kung ang gipangita is a red and an ace, so ang intersection nila would be, it could be an ace of hearts or an ace of diamonds. Now what? Next is B, the intersection of B and C. Yun siya, Jack, Queen, or King of Diamonds, and a card is an ace. So naabay Jack nga ace, Jack nga diamond nga ace, Queen nga diamond nga ace, or King nga diamond nga ace, or ace nga Jack nga diamond. No, if obviously wala may ace nga Jack nga diamond. So which means it's a null set, or we can use the symbol. Next is the complement of B, meaning dili Jack, dili Queen, dili King nga diamonds, pero red. So unsa may dili Jack, dili Queen, dili King nga diamond, pero red. So it could be an ace of diamonds. So ako na lang i-dot until 10 nga diamonds. Dili na to i-appeal si Jack, Queen, King. Red man ni sila. Then we also have another group of red, which is hearts. So that's ace of hearts until King of hearts. So these are the possible outcomes. Okay, engage 1. So please answer these in the engage portion of our module. You have this set, no, and you have the different the sample space and the different events. Okay, so for the answer, please show the values here. Si Rina, so in our engage part there, so isulat ninyo ang answer, picture, then send the link of the image of your answer. So sa inyong pag-answer, ibutan nila A. So, kung ano yung A union of C. Dayon, ibutang dayon ninyo ang tanang possible outcomes. Next, how do we count sample points within a sample space without writing all the possible outcomes? Kay mabot og 1,000 ang atong sample space. Do you want to write all the possible outcomes ng 1,000 ka buok? So there are some methods wherein we can calculate or count the sample points or the possible outcomes within a sample space. One of which is under, or one method is a multiplication rule. So we have different rules under the multiplication rule. One is when we have two ways, two groups of possible outcomes. For example, n sub 1 refers to the possible outcomes of the first event, n sub 2 refers to the possible outcome of the second event, and when two operations or when two events are considered together, then the number of ways would be n sub 1 times n sub 2. So example for that is, how many sample space or sample points rather are there in the sample space when a pair of dice is thrown once? So one die contains 6 possible outcomes. The second die contains another 6 possible outcomes. So if we will denote n sub 1 for the first die, the number of sample points or the number of possible outcomes for the first die is 6. For the second, kay 6 po. Siyempre, pareho na silang die. Which means, if we want to count all the possible outcomes when tossing the dice, these two dice, once, no, it possible outcomes, kung atong ilista, possible outcomes is it can be 1, 1, 1, 2, no, 1 diri, then 2, 1, 3, 1, 4, to be 5, 1, to be 6, 1, and so on. So, kung ato lang goal is to calculate the sample points, which will be used later in getting probability of events. So dito tapad doon sa probability. But if we want to know the pila tanan ka sample points, then you have to multiply n sub 1 and n sub 2. So that's 36 times 36. Okay, and resolution. Again, so I have listed here the possible outcomes. Kung atong tagsa-tagsaon yun, you count them. So 1, 2, 3, 4, 5, 6, and 12, 18, 24, 30, then 36. There are, which means 36 possible outcomes. However, if we will use rule number 1 in the multiplicative rule, so let's just kani and multiply them, you have 36. Therefore, in throwing a pair of dice, the possible sample points or possible outcomes is 36. Next, a developer of a new subdivision offers prospective home buyers a choice of Tudor, rustic, colonial, and traditional exterior styling. Now, in ranch, two-story, and split-level floor plans, in how many ways can a buyer order one of these homes? Now, check the statements. You have choice of Tudor, rustic, colonial, traditional. These are types of exterior styling. Then it can be in a ranch, two-story, or split. These are types of floor plans, meaning natay duha ka events. First event is the exterior styling. Then the number of elements within exterior styling kay Tudor, rustic, colonial, and traditional, so 4. For the fourth floor plans, we will use n sub 2. The number of elements, the number of possible outcomes when uh, sa floor plan, you have ranch, two-story, and split type. So there are 3. Therefore, the buyer can have n sub 1 and n sub 2 ways. That's 12 ways of this home. So pwede din yung two-door nga ranch, two-door nga two-story, rustic nga ranch, rustic nga split level, and so on. Next, we have here a club which has 22 members. However, they need to elect 2 officers. One is the chairperson, the other is the treasurer. How many different ways can these 2 be elected? So if we will use n sub 1 for the number of possible outcomes to elect a chairperson, and n sub 2 for the possible outcomes to elect a treasurer. So pila man. We cannot use 22 times 22 here. Why? Because when, say for example, we want to elect first the treasurer. So when electing a treasurer, ang mapilian nimo kay 22 pa. However, when the treasurer is already elected, pila na lang may mabilin. Therefore, you only have 21 choices para sa chairperson. In the same way, if we want to elect first the chairperson, we have 22 choices among the members. So, if elect na ang president or chair, ang mabilin is 21 na lang. Therefore, there are 22 times 21 ways, or that's 462 ways in electing set of officers, chair and treasurer lang. So that's rule number 1. The rule number 2 is just an extension of 1. The difference is that rule number 2 will then now contains more than two events, no? Two different events. So say for example, nagtulo ka events, which means number of sample points for the next event will be denoted by n sub 3, or the number of operations is more than 2. So ang bottom lang is you multiply all of them. When you have 10 operations, so that's n sub 1, n sub 2, n sub 3, n sub 4, n sub 5, until n sub 10. You multiply them. Say for example, these two. So I'm going to assemble a computer by himself. He has the choice of chips from 2 brands, a hard drive from 4, memory from 3, and accessory bundle from Peña stores. Then another is forming a 3-digit number out from the numbers 2, 3, 4, 5, 6, 7, and 8. So we'll have 3 solutions. So Sam is going to assemble a computer by himself. He has choices. Sa chips, na ay 2 brands na iyang napilian. Sa hard drive, na ay 4. Sa memory, na ay 3 ka brand. And sa accessories, you have 5 local stores. How many different ways can Sam order the parts? So you have operations here, 1, 2, 3, and 4. So we'll use n sub 1 for the chips, n sub 2 for the hard drive, n sub 3 for the memory, and n sub 4 for the accessories. Then multiply them. You have 2, 4, 3, 5. So that's 120 ways to order the parts. Some can have 120 ways sa pag-order sa parts. So that's how we solve. So pwede kag say brand A ni chip, brand A ni hard drive, brand A ni memory, brand A ni accessory. Pwede po kag brand A ni chip, brand B ni hard drive, brand C ni memory, or brand B ni accessory bundle, and so on. So kung imo nang isulatan na, there are actually 120 possible groups or groupings or ways. That's rule number 2. Second example, for rule number 2, we have from the numbers 2, 3, 4, 5, 6, 7, and 8, we will form 3-digit numbers. Then how many numbers are there if a number is not allowed to be repeated in each 3 digits? So when repetition is not allowed, so meaning dili ito pwede mag-number of 222 nor 3 to 3. So dili sila pwede. These are not allowed. Dapat it can only be 234, 235, 236, 237, 238, 24, say 3, 245, 246, 247, 248. Basta wala number magbalik. So take note that you have 3 digits. You have first digit, second, and third. I will use here n sub 1. So kamoy bahala, you can put in n sub 1 here. But for me, I will place n sub 1 here. Example lang siya, n sub 2 and n sub 3. However, you can also use n sub 1 here, n sub 2, and n sub 3. It depends, no? Kamoy, it depends on us. It depends on you how you interpret the problem. But again, you have to solve them correctly. So that means 1, 2, 3, 4, 5, 6, 7. So if kaniya kong i-follow, there are 7 possible numbers na pwede na ko mapili for my n sub 1. For my n sub 2, since na may usa magamit ani, then there will only be 6 possible numbers. Tina na may duha na gamit, so we will only have 5 possible numbers. And multiply them, you have 210 ways. We can generate 210 3-digit numbers. Okay, engage 2. Can you answer this one? How many even 5 digit numbers can be formed from the digits 0, 1, 2, 3, 1, 2, 5, 6, 8, and 9 if each digit can be used only once. Take note of the condition, dapat even. So, even ang number. So 5 digits pa yun. So answer this on your engaged parts in your module. Another way of counting sample points, no, aside from the multiplicative rule, is the permutation. So it's arrangement, distinct arrangement, which is based on if you kani sila are examples of permutations. So you have these numbers 1, 2, 3, 4, 5, 6, 7 numbers pero 5 ra nga ito ang gamiton. So this is an example of permutation. Will only be ang atoang sample points or ang atoang n contains 7 digits pero ang atong kwaon lang at that time is only 5. So that's an example of permutation. And take note of nga sa permutation kay distinct, no, ang all parts, meaning dili magbalik-balik okay ang value. And how do we calculate them? We have theorems. First is using factorial. Okay, the number of permutations for n objects is just equal to n factorial. When we say n factorial, if you will expand that one, that's n times n minus 1 times n minus 2 and so on. Say for example, if our n, if ang atong object kay 5, therefore 5 factorial will be 5 times 5 minus 1 times 5 minus 2 times 5 minus 3 times 5 minus 4. So, dili na ka mo abot ng 5 minus 5. No. This is 1, this is 2, so mo ni sila pasabot. And this is 3, this is 4, and this is 5. And multiply them, that's 5 factorial. For example, this one, in how many distinct arrangement can we arrange the letters A, B, and C? So we have, count them, we have 3. Our n here is 3. So pila daw ka ways na to ma-arrange ang 3 kabuok. So that's 3 factorial. So you have 3, 3 times 1, 3 times 2. That's equal to 6. Next theorem is that the number of permutations for n objects taken r at a time is this one, NTR. This is the number of objects. This is the number of objects taken at a time. So when you have 10 objects and you will be only selecting 3, so you can use permutations. So kaganina, if you would recall, electing a chairperson and a treasurer, no, you have there 22 members, so your n will be 22, and the objects taken at a time is 2. So you will then use this notation, 22 factorial divided by n minus r. If you will be using this, I would suggest you start with the denominator. Say for example, this one. Our n is 22, so that's 22 factorial. Divide it by n, that's 22, minus r, that's 2 factorial. Then, how do you, if you would recall the previous slide, 22 factorial can be, again, we'll start with the lower portion, that's 20 factorial. So let's go back to the numerator. So that's 22 times 21 times 20. Now I would suggest stop at 20, same with the denominator. But 20 factorial is just 20 times 19 times. And when you expand this 20 factorial, pareha na sila sulod. Therefore, we can cancel this out. Using division, this would just result to 1. So therefore, 22 P2 is just 22 times 21. This is how permutations. Same you would recall our multiplicative rule. No, now that's rule number one. So they will have the same results. Another example: in 1 year, 3 awards, research, teaching, and service will be given to a class of 25 students in statistics. So if each student can receive at most one award, how many possible selections are there? So kung inyong tanawon, dili pwede magbalik ang usa ka student to kuha sa award. Then we can use permutation. So mo nay kamit ni permutation if in the condition kay one outcome dili siya pwede mo balik-balik o gawas. So we will use permutation. There are cases wherein mo balik siya o gawas, but that's not permutation. It's a different method. So again, we have 25 students and only 3 awards will be given. So in how many ways? So that's 25 P3. So 25. Again, you start with the denominator para na may basis. Asa mo muhunong diri sa numerator. So 25 minus 3 is 22 factorial. So which means muhunong ta sa taas sa 22 factorial kay murong yapon ay padulungan. We will just eliminate them. Now then, we'll have 25 times 24 times 23 or 13,800 possible selections. I think this is engaged. Yes, this is engaged 3. So we now have the third engaged portion. So answer this. You now have the difference ani nga engaged sa others. Katuban, okay ra to ma dili na to ni may buwan ang answers. Now in engaged 3, we now have the answers given. So all you need to do is to get or to write the solution. How did we get 2450, 225, 2258, and 22 and 2448? So again, show the solution. However, if you think if you think that these answers are wrong, like there are errors within answers, you can just write it and just show the solution. Okay, another type of permutation is what we call circular permutation, wherein when you arrange a group into a circular form, nag-circle mo, then how many ways daw ma-arrange na nimo? And the answer is just n minus 1. So when you have 10 members, you want to arrange them into a circle. And how many possible ways you can arrange 10 members in a circle? That's 10 minus 1 factorial, that's 9 factorial. Okay, another theorem is the permutation of indistinguishable objects. We'll have an explanation this one, or an example this one later. To get the values, ihapon mo pila tanan, whether nagbalik-balik, no? You have ihapon na nimo divided by for n1 pila ka buok, n2 pila ka buok, n sub k until n sub k pila ka buok. So k represents kung asa gitaman. So or in other words, when the number of ways of partitioning a set of n objects into R cells within n sub 1 elements in the first, n sub 2 in the second, and so forth. So this one can also be written in this manner. So you have this n, n1, n2, n3, and so on. Where you have, if you want to check, no, dapat when you add n1 and 2 until nr, equal sila dapat ni n. So if you have 10 objects, dapat kani si n1 ways, n2 ways, until nr ways should be equal to 10. Example. In a college football training session, the defensive coordinator needs 10 players standing in a row. Among these 10 players, there are 1 freshman, 2 sophomores, 4 juniors, and 3 seniors. So how many different ways can they be arranged in a row if only their class level will be distinguished? So without considering their names or gender, basta kay freshman na siya, basta kay sophomore na siya, basta kay junior, basta kay senior. So how many ways na nato sila ma-arrange? So 10 players, that will be our n. Kita pwede diri, so we'll just use the upper portion. So this will be our n. Our n sub 1 will be for the freshman. Pinakabuok, we only need 1. For the sophomores, duha. For the juniors, tulo kinahanglanon, apat rather. For the seniors, tulo lang ang kinahanglanon. So how many ways na ito ni sila ma-arrange? So using the permutation of distinguishable objects, so that's n factorial, factorial divided by n sub 1 factorial, n sub 2 factorial, n sub 3 factorial, and n sub 4 factorial. Now take note, n sub 1 plus n sub 2 plus n sub 3 plus n sub 4 is equal to 10. So okay na siya. Then we'll get an answer. So 10 factorial divided by 1 factorial, 2, 4, 3 factorial. That's 1 times 2. 1. Then kani 2 times 1 for this is for 1 factorial. This is for 2 factorial. 4 times 3 times 2 times 1 is for 4 factorial. 3 times 2 times 1 is for 3 factorial. So, here, you can eliminate this. Now, cancel them out. Then we can cancel out 4. Then, what else? You have here 3 times 2 times 1 is 6. We can cancel out 6. Then, you have 1 times 2 times 1 is 2. We can divide it from 10 or 8 since these are only our even values. So, it's either you divide 8 by 2 or divide 10 by 2. So when you divide 8 by 2, one your result. You divide 10 by 2, this is the result. And multiply them, you have 12,600 values. Please check if this is the answer. So this is how we use permutation of indistinguishable objects. Another use of permutation of indistinguishable objects is this. Okay, I will just discuss the solution for the second problem. This is in engage 4. The answer is 50,400. If you count all of them, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So your n is equal to 10. Your n sub 1 will be for the letter S. We count the number na si letter S ni gawas. Si letter T, you can use n sub 2. Si letter A, so i-select nyo ang mga distinct. No? So, C3, that will be our n sub 3. Isa pa mga letters S, T, A, then you have I. Pila ka si I. This will be our n sub 4. Then, another letter last is C. Pila ka ang C. Therefore, we will have 5 n's. You have to take note nga, kung i-add mo si n sub 1, n sub 2, n sub 3, n sub 4, n sub 5, the total should be 10. Okay. Show your solution. That's engage number 4. Again, I have told you earlier nga if mubalik ang object sa number of ways, we will use combination. Notation for combination can be this: n, then r, then n minus r. Or we can also use this notation, or this notation. There are again 3 possible ways in representing or showing combination of values. Now let's try this example. This example is a combination na siya sa multiplicative rule and combination. Okay. You have here, a young boy asks his mother to get 5 Game Boy cartridges. Take note, 5 yung kinahanglanon. From his collection of 10 arcade and 5 sports games. So, nadi siya 15 ka cartridges to all in all. But he will be only needing 5 out from the 15. Sa iyahang 15 ka collection ay 10 ang arcade, 5 ang sports. Pero, dapat ang makuha ni mother is out from the 10 arcades na ay 3, out from the 2 sports na ay 2. So, all in all, 5. Okay, now how do we solve this? First, we'll consider the arcades na ay 10 na ay tulo. We will use combination for this. Okay, we'll use combination for that. And n is 10, r is 3. So by, okay, kana siya. Then you have here, cancel out 7. What will be left is this. The answer is 120 ways. There are 120 ways di ay nga makakuha kag tulo ka arcades out of 10. Ano siya? Another, we'll consider 2 out of 5 sports cartridges. So that's 5 times 2. So that kani mo niyang calculation. Then you have 10 ways. However, kani siya, this is taking 2 and the other one is only taking 3. Pero ang gipangita is taking 5. So what we will do is that we will multiply kani siya, di ba? 3 man siya, 3 of 10. Kani siya is 2 of 5 sports. So makakuha kag tulo, duha, so 5 na siya. So that's 120 times 10. So there are 1,200 ways that this mother can get 3 arcade and 2 sports game cartridges. That's the use of combination. Okay, one example of permutation, if you're familiar with Lotto. The Lotto can, you can calculate the number of possible outcomes sa Lotto using permutation. When you use combination, pwede na nimo ma-apply sa itong swertres, itong tulo ka numbers. Because in a swertres, pwede ma-repeat si number. Pwede man ta magka output of 2 to 2. So, pwede na si combination. Pero kung dili gani pwede mubalik ang number, so that means you will use permutation. In Lotto, ang usa ka number dili na siya pwede mo gawas, no? Dili siya pwede mo balik rather. So, dili ka pwede mag 2 to 31 51 51. So, one number lagi na siya sa usa ka group ang unique ang numbers, no, within sa kanang magawa sa Lotto. So again, permutation for Lotto, combination for swertres. Familiar mo na nila. Now answer this in your quiz. Sa part sa inyong module, answer this quiz. How many distinct permutations can be made from the letters of the word solving? Then how many of these permutations start with letter L? So, okay, then another set, how many 3-digit numbers can be formed from digits 0, 1, 2, 3, 4, 5, and 6 if each digit can only be used once? How many are greater than 330? Clue is that most of these questions ay nasa either rule, multiplicative rule, or permutations. Okay, this would be all for the first lesson on probability. So thank you and see you on the next slide.